So this is a very simple program that you can see on the screen, which just prints hello world whenever you press enter. Okay, so what basically we are trying to do is we are writing a LEX code, okay, for performing lexical analysis. Okay, so what is lexical analysis? Lexical analysis is that it reads the input and it converts the input into tokens, okay, which is given as input to the next phase, that is syntax analysis. Fine. So what happens is, right now, since we are not using syntax analysis, so, we won't, what we'll do is we'll just match patterns and we will print something on screen. Okay, or we will, if suppose I want to count the number of words, then I will just increment the counter and I'll print the total count on the screen for now. Okay, because we are only using LEX. Fine. When we will study parsing techniques, that time we will need both LEX and YAK. So the tokens that are generated by this LEX program will be given to the YAK, okay, for parsing. Fine. But for right now, what we'll do is we'll just perform some action when a pattern is matched. Okay, so this is the very first program that, and very simple program that I have just written for making you people understand how to write code using LEX. Okay, so see, here you can see that there are three parts of the program. This is the first part. Okay, then we have double percent. So then this is the second part, and then again we have double percent, and then third part. So these double percent are there to indicate that this is the end of the first part, which is declaration part. Okay, then see, here in the first part you might have seen this percent and opening curly bracket and percent and closing curly bracket. Fine. Now what happens is, whenever you compile your LEX code, it generates a C.C file for you. Okay, now all of you might have already done with your assignment one, because today you need to submit it. So you must have seen that when you write program for whatever assignment that I have gave, like counting the words or counting the number of lines and so on, you need to write that the line of code actually is more. Fine. What this LEX tool does is it writes that .c file for you. So here in this .l file, so LEX, if you are writing this code, okay, you need to give the extension as L. Fine. So this .l file only needs the patterns, that is the regular expressions for matching the lexemes. Fine, that's it. And it will generate a .c file for you. Fine. So this first part, this very first part, that is the declaration part, it consists of those statements that you want to put as it is in the .c file. Okay, I'll just repeat that, when you will compile this program, it will generate a .c file for you. Okay, and those statements that you want to be just copied into that .c file, you will write here in the first section of this LEX code, which is percent and within this percent curly bracket open and percent curly bracket close. Okay, so here I have written these two statements, undefined YY wrap and then defined YY wrap space 1. Okay, so I will let you know what is this YY wrap in just few minutes. But so this is the first section. Okay, now in the second section or the second part of your program, you need to write the regular expressions. Okay, so you need to give patterns. So regular expressions here are known as patterns. So you need to give patterns. Only one pattern that I have given here is this slash n, that I need to match. Okay, and if this pattern matches, then what action should be performed, so is written here. Fine. So here in this middle section, second section, you need to write the pattern and the action that you need to perform. Fine. Now in the third section, you can see the main function. Okay. Inside this main function, we are calling this YY Now this YY and YY wrap, these are the two inbuilt functions that you have in LEX. Fine. So I'll just share this document in which I have written about what is YY and YY wrap. So see, YY is a function of return type as integer, and lex automatically defines this YY function in this file. Now what is this file? This lex.yy.c, this file is generated when you compile your .l file. So as I said that, this lex code, it generates a .c file. So this is the .c file that it will generate. So always the name of the .c file that it generates is lex.yy.c. Fine. So what happens is this lex automatically defines this lex in this file lex.yy.c, but it does not call it. Fine. So you as a programmer need to call this file. So here you can see I have made just a call to this lex. Okay, you can think of this lex function call as the main function. Okay, so to execute this code, you need to call this, otherwise your program won't execute. Okay, the lexical analysis part, it won't perform that. So this is the main function that you need to call. So it automatically defines this function in the .c file that is created, but you need to call it here in the main. Fine. Now the second function is YY So YY so Lex declares the function YY of return type int. Again, it has a return type int in this file lex.yy.c. So again, this file which is generated by this lex tool, so it declares this function. Okay, so you can see that these are opposites. Like here what happens is the definition is included here in .c file, and you need to call this function yylex. For YY what happens? Only the declaration of this function is given in this lex.yy.c, and you need to define this function YY in your program. Fine. Now what happens? What is the use of this YY? So YYlex makes a call to YY when it encounters the end of the input. Okay. So by default, this YYlex function internally calls this YY function when it encounters the end of input. Fine. If this YY returns 0, then it assumes this YYlex assumes that there is there is more input. Okay, and it continues scanning from the location pointed by YYin. Now YYin is basically a variable. It acts as a pointer, and it points to the location from where it is reading the character. Okay, so this is also an inbuilt variable which points to the character which is read. Fine. And if this YY function, it returns a non-zero zero value, usually 1, then this YYlex terminates the scanning process and returns 0. Okay, so what happens is this YYlex actually calls this YY to check whether the input is completed or done, or what I mean, if you read about this YY then you will find the statement that it says this YY wrap is called to check whether the input is exhausted. Okay, so these are the two input, these are the inbuilt functions that you have in LEX. Okay, and you need to use these two functions whenever you write the code. Fine. So here, see, this is one type that you can do. I have defined this YY wrap and I've given this value as 1. Okay, this is one method. In the other program that I'll show you, I have just what you can say defined YY wrap with empty body. Okay, so what happens is I'll again repeat for the students who have joined late, that this is a very simple program that just prints hello world after it encounters slash n. So slash n is the pattern that I have given here, and it just prints hello world. Okay, so how will you execute this code? So you can look here down at the terminal. What you need to do is you need to first compile using this command flex. Okay, since I'm using Windows, again I'm telling you I'm using Windows, so I have installed flex and bison in my machine. Okay, so flex space the name of the program. Okay, and you can see this is my current this is the directory in which this file is stored, hello world. Okay, so flex space and the program name is hello world dot l. So always this LEX program is to be given the extension as dot l. Okay, and you press enter. When you press enter, if there are no errors, then this means that it is compiled and it has generated a .c file for you. So okay, Vedant is asking me that why we need these flex and bison. See, flex and bison are the tools. Flex is basically used for lexical analysis process, and bison is used for parsing and semantic analysis and intermediate code generation. Fine. Now when you want to build or develop a compiler, you need to write a code for that. Yes, as we have seen that you all know that compiler is also a itself is a program, right? So if you are building a compiler for a particular language, you need to use some language to write the code of the compiler. Fine. Now, suppose if you are using C language, okay, since you all know C, and if you want to design develop a construct a compiler, you use C language. Okay, so you must have seen that the programs or the assignment one that I gave you, it consisted of those what you can say questions that were related to lexical analysis part. Okay, so counting the number of words, counting the number of lines, and all those things. So that is the part of lexical analysis, right? So for lexical analysis part, what you have done is you have written a C program for that. Fine. Now when you write a C program, the number of lines of code is usually very large. When if you consider that you are constructing a compiler, then the code of the compiler is actually very big. Okay, so these tools like flex and bison, these tools are meant for when you use these tools, then the line of code reduces. Okay, so most of the work of the programmer is reduced when you use these tools like bison. Okay, now when I will when I'll explain about more programs like this verb.l and countwords.l, you will understand that if you write the same code, or if you write the C code for the same thing, then the number of lines will be more compared to the number of lines that we need here when we use this tool. Okay, so it makes your work easy. Okay, so these two tools are meant for the person who wants to construct a compiler. So I hope I have given you, your answer to your question and you understood it. Yes. Okay, so let us move ahead. So what we had done here is I had compiled this Flex program, and since there are no errors, that means it has generated lex.yy.c file. Okay, so when we look at this, so you can see this file. Can you see here? lex.yy.c, this is a C file, okay, that is generated. Fine, that is automatically generated. Fine. Now, when I open this file, you can see if you look at this lex.yy.c, you can see a C code that is automatically generated for you. Okay, so this is the code that is generated by this Flex tool. Fine, so it generates the code, and you can see this code is so big, I mean, compared to the program that you have written in using Lex. Fine, so this is the code that is generated. Now let us move ahead. So we have now .c file available with us. Now to execute, what we need to do is we need to first compile this .c file. Okay, just a second. Yes, so what I need to do is I need to compile that C code and then I need to execute. Okay, so gcc space lex.yy.c. Fine. So the .c file that was generated is now compiled, and we'll say A because a.exe is generated. Fine. So when I say A, then see it is waiting for me to give input. Okay. So suppose if I write that I am at IIIN, fine, full stop, enter. So you can see what is displayed. This hello world is displayed because I have pressed enter, that is /n, and I have given here that this is the pattern /n, and what I need to do, I need to print this hello world. Now you must be thinking that this I am at IIITN is also printed, and after that hello world is printed, right? So what happens is, all the characters that are not matched by any of the pattern that you give here in this section, it prints that character in the console. Okay, so I have not written any pattern to match these characters I space am space at space IIITN and full stop. I have only given a pattern for /n. So you can see that /n is not printed. Otherwise, the cursor would have moved to the next line here. Okay, so when I have pressed /n, instead of /n, it is printing this hello world. Okay, so it is again waiting for me to give some input. So if you give again some input, say I'll just write a single word, that is compiler, and I press enter. So again, this compiler word, this is not matched by any pattern, so it is printing it as it is, and for this /n, that is enter, it has printed hello world. Okay, so to terminate this execution, you need to press Ctrl Z and come out of it. Fine. So this was a very, very easy and very, very simple program for just your understanding that how you need to, write a code in Lex.